Hello YouTubers and fellow hams. Well, today I'm going to be building an antenna. Haven't done that in a little while, and I had an idea. Well, a long time ago I had an idea that turns out it's not a very new idea, but I wanted to build one for a while. Spiral loops have been around forever. They were, in the early days of broadcast, even a common receive antenna. And as early as in, just post World War I, I think, they were used as portable transmitting antennas as well. And I've wanted to do a spiral loop for quite a while as a transmitting antenna just to see how it performs. Their size is kind of compact. Yeah, it's an interesting little antenna. Now, there is a design already put together. All the work's already been done, the hard work, calculating and figuring dimensions and everything. Frank, N4SPP, has an excellent site where he's detailed his construction of spiral loop transmitting antennas. So I'm not going to cover over ground that's already been covered. I'm not going to recalculate and do all that. He's already done that work. I'm just going to build it and then see how it performs. His work is based on work by Richard SM0VPO. Who originally designed this loop, and then Frank refined it, Frank N4SPP. Just want to make sure I get that right. So kudos to you guys. And I'm going to build mine with what I have available. I don't have the money right now to go out and buy PVC, which would be the right way to do it. The way Frank set it up definitely is the way to do it with the PVC pipe. It's great stuff to construct with. I used it for my 3-foot magnetic loop, great stuff to work with, but I can't afford to buy any, so I'm going to use what I've got. I've got some wood and a platform that I've tested stuff on, other magnetic loop experiments on, so I'm just going to reuse that and build up my loop. So let's go downstairs and we'll get cracking on this thing. Well, I spent a little time this morning down here on the bench cobbling together the framework for the antenna. I'd really like to do it nice and clean and pretty with PVC, but I think I mentioned I can't afford to go down and just pick up some PVC. So I got to use what I have, and I've been using this stand off and on for various experiments for quite a while, so hey, why not continue to experiment with it? So what I've got is a cross shape here. This is going to be the total size of the spiral loop. The design calls for somewhat over 70 centimeters diameter. And this piece that I had here was about 10 centimeters too short. I think it was like 66 centimeters total, so I got 60. So what I did is I cut this piece to 71 to make up the difference. It's okay, you only have to be close. You don't have to be super precise. The tuning capacitor is going to give you a range probably from below 20 meters to above 20 meters, hopefully. We'll find out after we get it wired. So I mounted these pieces together, and I've marked off points for the wire and put nails in to wrap the wire around so I can stretch the wire around this thing. The spiral loop is basically a magnetic loop. You'll have multiple turns on the outside that spiral inwards. In this case, 3 turns. Well, 3.5 or so, because the 4th we end up here at the capacitor. And the variable capacitor will be across the outer loop. And then you'll have a smaller delta-shaped coupling loop that's going to terminate here at this SO239. So the coax cable can come straight out in the null of the loop and off to the radio. So I've got a loop of wire from an old antenna project. I'm going to start doing the outer loop on this thing. I'll get set up to do that, move the camera over and reposition it, and film some of me winding this guy. I mounted this piece on the front of this piece, and so I've got the nails on the back side of this and the front side of that, so they're on the same plane. So the loop will be spiraled right there between these two boards. Alrighty, let me move the camera, get the soldering iron heated up, and we'll start winding a spiral loop. Well, this is the tedious part, and part of what makes it tedious is I'm working with a big loom of wire here that I had, like I said, off an old antenna project, so I've got to pass that through, and each pass, wrangle the wire and then straighten it out. Wind it around the nail, one little turn. That's going to anchor it. It's not going to cause enough inductance to make any difference. Pull the loom back through. Loom, I guess that's the right term. Almost done. Like I said, it's only 3 turns, so it really doesn't take a lot of time to do this. Get over there. In fact, I'm on the last pass right now. This didn't take much to do at all. Okay, now this is gonna, oh, that's it, a splice. That's all right. Come around there, and it's just gonna come down and hook up to the capacitor there, so I can cut that about there. All right, and that's the outer loop wound. Now I just have to do the little delta-shaped pickup loop here. And I'm going to use the red wire for that, just to make it look interesting. So I'm going to have to go from there, up to there, up to there, down to there, over to here. So I'm only going to need about, take an extra 6 inches there, about that much wire. Now, I need to temporarily take this connector off of here so I can clean its ends up and put a wire on it. I just mounted it on there when I was setting everything up and gauging how it's going to fit. This SO239 was actually, you can see, it's got some labeling on that metal. It was part of one of those super cheap old CB type SWR meters from the 70s. You see those at Amfests occasionally for almost nothing, or in a box full of junk for nothing. That's a great way to get some SO239 connectors. The hardest part was putting together the frame. Actually doing the wiring is super easy. Except that my back is killing me. Tell you what, the problems with my back are getting worse exponentially. It's getting now to where I take a little walk down to the river and back, which I've done like every day for the past 2 years. It's a mile total. And on my way down, I'm walking pretty good, pretty quick. By the time I get back home, I'm hobbling along pretty slow, and it's painful. Okay, so this is going to come over here. And then it's going to come up. To this side. Let's around that nail. And you can see that. And then it's going to come back here. So that's our coupling loop. And then I just got to trim this to the right length and hook it on that eyelet. The measurements on these things, 70 centimeters or so total, with 6 centimeters between these two and these two. And then was it 2 or 4? No, I don't have the diagram up. I think it's like 4 centimeters here and 2 centimeters up here for the coupling loop. And then that's just a delta shape. Okay, now all I got to do is solder that, and the antenna will be ready for testing. Just that easy. It's a real simple antenna to make. Like I said, the hardest part by far was getting the framework together. Now, the design, as you saw on that web page I showed earlier, he used a PVC pipe with a cross piece, and he drilled holes through the pipe. All right, there's our coupling loop and our outer spiral loop coming down to a capacitor. So, like you said, the hardest part's getting the frame. And once you got the frame, wiring it up, pretty easy. Okay, to test this thing, I need to profile its range. And I don't know if you've seen my other video on using an SDR to profile a magnetic loop. But if I can hook this up to a software-defined radio where you can look at large swaths of spectrum. Like on the SDR Play, I can look at 10 megahertz of spectrum at a time. So I'll set it to like 5 megahertz around the 20 meter band, hook this up, and what I should see is a bump in the noise at the resonance point of this antenna. And then by turning the capacitor, I'll be able to move that bump across the spectrum, and I can see the range that the antenna covers. So I'm going to go get the SDR Play. I'm going to bring it down and hook it up to my bench computer here and capture the screen, and we'll see what the range is on this guy. And if we're fortunate and it falls well within the or around the 20 meter band, then we'll take it upstairs, hook it up to a radio, maybe do some whisper testing and try to make a QSO on it. So on we go. Okay, as you can see, I have the SDR Play hooked up to the antenna. And sorry about the camera motion here. But over there is the bench computer. And it is running cubic SDR. And I'm capturing that screen, so I'll just pop that over here onto the main screen after I reposition this. There we go. Now, on cubic, you can see that there is a bump. That's interesting. It's picking up noise, I think, from my digital recorder. But you can see that there's a bump all the way up there around 17 megahertz. I'm going to reach in here and I'm going to turn the capacitor. And see how that bump moves? There's a little bit of a delay, like about a 1 or 2 second delay while the software processes the information. But as you can see, I can move that bump right through the 20 meter band. I've got some interference and noise down there around 12 megahertz, but wow, this thing is covering quite the range. It's going, let's fully mesh the cap. And I'm going to zoom out. That's below 11 megahertz. There's 11. So this probably gets down to 30 meters. 12, 13, there's the 20 meter band there. I can get up into 17 meters. And when the capacitor is fully unmeshed, I'm somewhere above that. Just below 15 meters. Wow, look at that. It can almost get to 15 meters. I'll have to see with the radio. Looks like we get right to 21 megahertz. And with the capacitor fully meshed, bottom end, just maybe just gets close. Yeah, 10.5 megahertz. So with this capacitor, I've got quite a range. We could do with a much smaller capacitor. Ideally, I think what I'd want to do is I'd want to measure the capacitance where that bump is around 20 meters and use a much smaller trimmer to cover just the 20 meter band. But the band pass is going to be pretty good on this thing. It's not going to be quite as narrow as a regular magnetic loop. So I guess the next thing to do is let's take it upstairs, hook it up to the radio, and do some on-air testing. All right, we've got the little loop hooked up to the radio, and presently that is doing some whisper broadcasts. Okay, you can see the Yaesu is presently transmitting. Now, using whisper, I'm using half a watt. I like to test with a half a watt on whisper. I really want to go over the low end, you know, and just see what's happening. It's a bad day on 20 meters. Here's what band conditions we're showing. And I went and looked at space weather, and the solar wind is way down in around 350, and the solar flux is 74. So yeah, it's a terrible day on 20 meters. And here is a reception report. I'm picking up stations down in Dallas and out there on the western edge of South Dakota. 900 miles was the longest distance. And a transmission report. Somebody down near Jacksonville picking me up with 500 milliwatts. So hey, it's at least getting out. Just finished its transmission. And of course, I wanted to compare, so I have connected up my big loop. So presently I've got the big 3-foot loop hooked up, and it's doing some more whisper transmissions and receptions. And what I'm finding is that I'm hearing a lot more out to the west, all the way out to the coast, actually. So it's not doing as well as the big 3-foot loop. That is to be expected. And as far as transmission goes, let me load that. Yeah, I'm being heard way down there in Texas and up Halifax, Jacksonville. So the 3-foot loop is doing better here inside the house, but you know, you'd expect that. But the little loop is definitely working. So the little spiral loop, it gets out. So one thing I know a lot of you guys are wondering about on this spiral loop is, what is the bandwidth like? How does it compare to a regular magnetic loop? Well, it's definitely wider. So right now I'm seeing the lowest, which I'm reaching about 1.2 to 1 at 14.037. So let's say 14.04. And if I move down until I hit 1.5 to 1, there's 14 megahertz. Let's go the other direction. 1.5 to 1 at 14.09. So I was at 14.037 So yeah, its bandwidth is on the order of 60 to 70 kilohertz, whereas a normal 3-foot magnetic loop will have a bandwidth from where you hit 1.5 to 1 SWR on either side of around 8 to 9 kilohertz. So this guy is almost 10 times the bandwidth of a regular magnetic loop. This is much wider. That means you don't have to tune it as often. If you're moving around a little bit, doing digital modes or RTTY or CW, you don't have to retune the antenna as much as you do with a regular magnetic loop. So that's a plus with this design. So that's the spiral loop. It's an interesting little magnetic loop, a little broader than the regular magnetic loop. Performance, well, it's small. It's a small antenna. As I said, I see about the same performance that I saw from my junk box loop. It might be a little bit better if it was a little bit cleaner construction, admittedly. I just kind of threw it together, but that's kind of the point. It's an antenna that you can just throw together pretty easily. It doesn't take a lot of work. So I will link the web page below with the original design that I was looking at for you to peruse if you want to go ahead and build your own. And maybe someday I'll pick up some proper materials and build a cleaner copy of it and maybe get a little bit better performance. But it does work. It absolutely does work. There you go. I hope you enjoyed the video. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.